Welcome. So in this video we will learn about a method given by FSSAI, adopted by FSSAI for the detection of foreign fat in milk. That's the method number is FSSAI 0101022022. Okay. This method make use of the dual purpose milk butyrometer. Now we know that this is the normal butyrometer which is closed at one end, so here it is closed, but where in case of modified butyrometer it is opened at both the ends. Here we can see, and then here on the top we can place a silicone rubber that should be made up of good quality. So here we can close it by using the silicone rubber, and that this can be removed after the extraction of fat. Now this dual purpose butyrometer, why it is called so? Because it is having two purpose. First is to determine the fat content. We can determine the fat content immediately from the milk. We can determine the fat content, and also simultaneously we can also check the purity of milk fat. So we can determine the quantity as well as quality of the milk fat by this method. Okay, so this method make use of the dual purpose butyrometer, and this butyrometer is having opening on both the sides, has written both ends open in the case of Gerber butyrometer, and then we can simultaneously determine the quality and the quantity of milk fat. Now simple and rapid testing of milk fat purity using BR reading of isolated fat at 40 degrees Celsius using formula. So we will milk will be there, and then by the normal procedure which is there for determining the fat content in milk, we will determine the fat content in this dual purpose butyrometer, and then after fat extraction we will take out the fat from the top by using a syringe or by making use of any capillary. So we will take out the fat from the top, and then we will place a drop on the butyrorefractometer, and I will take the reading at 40 degrees Celsius. But here in this case whatever BR reading is there, that has to be multiplied by 1.08. This 1.08 is the correction factor which is to be applied. This is because of the hydrolytic effect of the Gerber acid on the fat. So since Gerber acid is causing the hydrolysis of fat, so this correction factor is to be applied. Now test is applicable at reception dock for accepting or rejecting the milk. So it becomes necessary, as already told. So since vegetable oil can be adulterated directly into the milk with the use of emulsifiers like detergents, so it becomes necessary that when milk arrives at RRMD, it should be checked for its purity, and this method can help in determining the same. So this method was earlier adopted by BS, now also adopted by FSSAI. Now fat to be isolated for taking the BR reading. So fat can be isolated either by modified Gerber method that we have seen, or if we are not having the dual purpose butyrometer that's shown in the previous slide, then we can make use of solvent extraction method also, in which we make use of Rose-Gottlieb method, which we make use of diethyl ether and petroleum ether. And again you can watch this video in this channel for Majornier method for determine the fat content in different products. And also the fat can be extracted by cream extraction method also. So in cream extraction method, what you have to do, you have to first separate the milk fat from the milk sample by centrifugation. That is milk fat or the cream, you can say here. You have to separate the cream from milk sample by centrifugation at 5000 times G for 10 minutes at 4 degrees Celsius. Now carefully remove the cream plug, and then collect the cream in aluminum dish. You collect the cream in aluminum dish, and obviously then you heat the dish over burner till ghee formation take place. Now once the ghee has been formed, you filter the ghee residues and take the BR reading of ghee and incorporate the results. Okay, so anyhow if we could we can extract the fat using solvent extraction method or by cream extraction method, wherein we are separating the cream and then heating it to have the ghee, and then we will filter the ghee, and then sample will be ready for its placing in butyrorefractometer to have the BR reading. But in case of Gerber method, we have to apply the correction factor. For other two methods, there is no corrective factor that is to be applied. Okay, now let us see modified Gerber method. Which say here, this I have already told you that modified butyrometer or dual purpose butyrometer is having opening at both ends, at the top also, the stem end also here, and the bottom also here. We have both the opening on the both of the side. So isolate the fat from milk by Gerber method using specially designed milk butyrometer which is both open at both ends. Close the stem end opening with a good quality acid resistant silicone rubber. So silicone rubber can be placed over here. Okay, now we will determine the fat content in milk by usual Gerber method using this butyrometer. So in this we will add 10 ml of Gerber sulfuric acid, then 10.74 ml milk will be added, and 1 ml isomalcohol will be then added. Then you close the neck side with a log stopper and mix the contents and centrifuge at 1100 rpm, approximately 300 times G, for 5 minutes to get a clear fat column. So you will have a clear fat column from on the top. Now you remove the silicone stopper from your hair. You can remove the silicone stopper from the stem side and take out the fat from the stem of the butyrometer using either a capillary or syringe. This fat, once extracted, you place it on the prism, which is to be cleaned with dry ether before use, and then temperature to be maintained at 40 degrees Celsius, because BR reading is always taken at 40 degrees Celsius. At this temperature your fat is in uniform liquid state. And then in modern butyrometers, so temperature control mechanism is there. We have temperature control at 40 degrees Celsius if you give the command for the same. Now you have to calibrate the butyrometer by standard liquid. So standard liquid solution are available with the they are initially provided by the manufacturer also, or you can use any CRM for calibrating the equipment. And then after calibrating, you clean the prism again with diethyl ether, and 1 to 2 drops of extracted fat you place on the prism. Then you can wait for 2 minutes so that the temperature is at 40 degrees Celsius, or equilibration has been reached. And if the temperature is not 40 degrees Celsius, then correction factor is to be applied. Say if it is obviously if higher temperature will be there, then BR reading will be lower, and then 0.55 is to be added. And if the temperature is lower, then obviously BR reading will be higher, and 0.255 correction factor is to be subtracted from the BR reading which is observed. Now in case of modified Gerber method, I have told you that you have to multiply it by 1.08. This is the correction factor. Why? Because Gerber acid is acting on the fat and causing its hydrolysis, so thereby lesser BR reading will be observed. So by so many trials, the correction factor is arrived at 1.08, and by this method greater than 10% vegetable oils if added in milk can be detected. And the exception is palm oil and coconut oil, because these two oil are problematic fat, so they create difficulties in their detection by using this method. Okay, so this way we can determine the foreign fat in milk by using a modified butyrometer, and also anyhow we can extract the fat and then using the butyrometer.